The next two properties of the Cobb-Douglas function are relatively simple, and you do not need to do any derivations for it. You just need to memorize it. So these are basically the last two properties of the Cobb-Douglas function. The next property says that the factor intensity of a Cobb-Douglas function of the form Q equals to A k times alpha, k to the power alpha, L to the power 1 minus alpha will be determined as L by K will be in the ratio 1 minus alpha to alpha, and higher, remember, higher the L by K ratio, it implies more labor-intensive technology, and vice versa. Lower the L by K ratio, more capital-intensive your technology is. Once again, remember, L by K, in the numerator you will have the exponent of labor from the production function, and in the denominator you will have the exponent of capital in the denominator. The last property of the Cobb-Douglas function, which we are going to discuss, simply states that two firms which have the same K, same L, the same alpha and same beta might still end up producing different levels of output. And this is because of the difference in the parameter A of the Cobb-Douglas production function. And this parameter is taken to represent the efficiency of organization of the production, which may differ from firm to firm, even if they use the same amount of capital and labor and they have the same parameters alpha and beta. So it could represent efficiency in form of organization, in the form of better entrepreneurship, and several other not so easy to quantify qualities, right? So larger the A of the production function, the more efficient the firm will be. Let me repeat. Larger the value of parameter A, the more efficient the firm we are dealing with. So the importance of the CD function, or the reason it is so popular, is simply because the Cobb-Douglas production function is in keeping with the marginal productivity theory of distribution, which says that each product is paid according to, or each factor is paid according to the marginal product, value of the marginal product. And as you can see in the Cobb-Douglas function, as it satisfies the Euler's theorem, if each of the factors are paid according to the marginal product, value of the marginal product, then the total output gets distributed between labor and capital in the respective proportions of alpha and beta. Similarly, it is simpler to derive the marginal product of the factors, and we can show that the marginal product of the factor depends on the quantity of factor being employed. Similarly, the slope of the isoquant, that is the MRTS, can be determined very easily if you know the parameters of the function alpha and beta, and then all you need are k by L. So MRTS is actually alpha by beta times k by L. The elasticity of factor substitution of a Cobb-Douglas production function is always equal to 1, irrespective of the kind of technology or the factor proportion in which you're using capital to labor. The factor intensity, that is, whether it is relatively more labor intensive or relatively more capital intensive technology, can also be easily found from the Cobb-Douglas function. Since the factor intensity is nothing but the ratio of the exponents of k and L. So higher the k by L ratio, the more capital intensive the technique, and lower the k by L ratio, the more relatively labor intensive the technique of production. Finally, the efficiency of production of different firms can be estimated and understood by comparing the values of A in the production function. Another favorable property of the Cobb-Douglas function is that the returns to scale is easy to calculate. You just need to sum up the exponents of capital and labor in the production function. Having said all this, we do have certain limitations of the Cobb-Douglas function. So that is what I want to discuss right now. The limitations of the Cobb-Douglas function. Like I said, since the elasticity of factor substitution is equal to 1 for any Cobb-Douglas function of any degree of homogeneity, it cannot be used to handle real-life empirical situations where the elasticity of factor substitutions may not be equal to unity. Another problem is that of aggregation. Even if you know that each firm produces according to a particular Cobb-Douglas production function, it is not possible to aggregate the production functions across several micro firms. So that's another drawback of the Cobb-Douglas function. Similarly, we know from experience and from empirical testing that labor and capital are not always homogeneous. And the Cobb-Douglas function essentially rests on the assumption that all units of labor and all units of capital are homogeneous. We know that even amongst labor, there are different types of labor. There is skilled labor, unskilled labor, and so on. Capital, all units of capital are not homogeneous because capital of an older date will be less efficient, whereas capital which uses more modern technology will obviously be more efficient. So this assumption of homogeneous units of labor and capital is very unrealistic. And finally, the most popularly used form of the Cobb-Douglas function is the constant returns to scale Cobb-Douglas function. In many empirical studies, it is the constant returns to scale Cobb-Douglas function which has received the most attention and is the most popular. However, many economists, especially empirical econometricians, have criticized, saying that a Cobb-Douglas function of constant returns to scale is an arbitrary assumption, and it is not based on any available factual data. While it may be the case that sometimes firms produce at constant returns to scale, this might not be a reasonable assumption to make under every situation. Now remember, the constant returns to scale once again simplifies the various assumptions, the factor intensities, the fact that it is very much in agreement with the marginal productivity theory of factor pricing and so on. Marginal productivity theory of assumption. So it has been favored for its mathematical simplicity. However, in empirical real situations, this constant returns to scale Cobb-Douglas function may not fit each and every situation seen or being studied. So these are the limitations of the Cobb-Douglas function. If you have any doubt, please do get in touch with me. Thank you very much.